Okay, these are some of the graph problems from section 4.3. This is number 21. And we want to use the graph of the function to estimate where f prime and f double prime are 0, positive, and negative. Well, again, this is our function, so remember the f prime will be 0 whenever we have horizontal tangents, so it looks like this is going to be where either right here we have a horizontal tangent, that's where the slope is 0, because remember the derivative is the slope, or there, when the slope is 0, right there. Either there or there. So where is that going to be 0? Well, if I just look and make a vertical line, it looks like it's going to be 0 right at -1 and right at +1. Okay, so it's going to be the derivative will be 0 at +1 or -1. Okay, these are the answers I have in my teacher's edition, so you can look off of there. And we'll verify that. Okay, now, where is it going to be positive? Well, it's going to be positive. The derivative is the slope, so it's positive whenever the slope is positive, so whenever I'm going uphill. So right there, it's going to be positive from -infinity to -1. Here it's going downhill, and here's going back positive, and from 1 to infinity. So it's positive from -infinity to -1 and from 1 to infinity. When is it negative? We'll write in here in between these 1 and -1, it's going to be negative. So it's negative between -1 and 1. So that's when the derivative is negative. In this case, remember we'd say the function is decreasing on the closed interval -1 to 1 because the derivative is negative. But we're just asking you on what intervals is it negative. So it's negative from, so that'd be the open interval, -1 to 1. Okay? Now let's take a look at the second derivative. That's always a little more fun. And that's going to have to do with concavity. All right? So when is the second derivative 0? Well, that's going to be when we have a point of inflection, and that's when concavity changes. So you can see here, definitely the function is concave down here, and it's concave up. Sometimes we say it's concave up, it'll hold water. Concave down, it won't hold water. All right, so right here, this is concave up, this is concave down, and it looks like it changes right there. So my point of inflection is at x equals 0. That's where it changes. That's where concavity changes. That's easy to see. And where is it positive? Well, it's positive when it's concave up. So it's concave up here. So it's going to be positive from 0 to infinity. So this keeps going out. And it's going to be negative when it's concave down, which would be -infinity to 0. All right? So that's number 21. So I hope that helps.